Imagine leaving Earth forever, leaving behind every planet, every moon, and every familiar world in our solar system. Your destination is Proxima Centauri, the closest star to the Sun. A tiny red star located more than 4 light-years away. That may sound close on a map of the galaxy, but the reality is almost impossible to comprehend. With today's fastest spacecraft, the journey would take tens of thousands of years. Entire civilizations could rise and disappear before you arrived. Generations would live and die during the voyage. And yet, Proxima Centauri is still the nearest star to us. Tonight, on What If Beyond, we will explore the terrifying journey to our closest stellar neighbor. How long would it really take? Could humans survive such a mission? And what might be waiting around a distant red sun that no human has ever seen up close? But before we continue, tell me something in the comments. What time is it where you are right now? And from which city are you listening? I always enjoy seeing where these journeys through the universe are being heard from. And if you enjoy documentaries like these, consider subscribing to What If Beyond. Now, dim the lights, get comfortable, and let's begin the terrifying journey to Proxima Centauri. The first thing to understand about Proxima Centauri is that it is close. At least, astronomers call it close. It is the nearest known star to the Sun. The closest stellar neighbor humanity has, a tiny red point hidden in the darkness belonging to the Alpha Centauri system, sitting just over 4 light-years away from Earth. 4 light-years. The number sounds almost gentle, almost small, compared to galaxies millions of light-years away, compared to quasars shining from the edge of the observable universe, compared to the enormous cosmic distances we hear about in astronomy. 4 light-years sounds like almost nothing. A short distance, a nearby star, the first step beyond the Sun. But that is the illusion, because the moment we stop saying the number and begin imagining the journey, Proxima Centauri becomes terrifying. Not because it is dangerous in the way a black hole is dangerous, not because it is about to explode, not because it is hiding some impossible cosmic monster, but because it reveals something far colder. The true scale of space. Proxima Centauri is the closest star to us, and still it is so far away that no human spacecraft has ever come close to reaching anything like it. Light itself, the fastest thing in the universe, needs more than 4 years to travel from Proxima Centauri to Earth. That means when we look at it, we are not seeing it as it is right now. We are seeing light that left that star more than 4 years ago. A faint red message crossing the darkness at the greatest speed nature allows, and still taking years to arrive. Now imagine something slower than light. A spacecraft, a machine, a human ship, a vessel carrying air, water, power, shielding, food, and fragile human bodies. Suddenly, 4 light-years no longer feels close. It feels almost impossible. The Moon took astronauts about 3 days to reach. Mars would take months. The outer planets take years. Voyager 1, the farthest human-made object ever sent from Earth, has been traveling for decades. It crossed the outer reaches of the solar wind. It entered interstellar space. It became our first messenger into the vast region between stars. And yet, it is still nowhere near Proxima Centauri. Not even close. If Voyager 1 were somehow aimed toward Proxima Centauri, the journey would take tens of thousands of years. Tens of thousands. Longer than recorded human history. Longer than the rise and fall of ancient civilizations. Longer than the time between the first cities and the modern world. A machine could keep drifting through space while languages disappeared, nations changed, coastlines shifted, and entire cultures became archaeology. And still, the nearest star would remain ahead. That is the first lesson of Proxima Centauri. It is not just a destination. It is a measurement of human limitation. It shows us that leaving the solar system is not the same as reaching another star. Those are two completely different achievements. A spacecraft can leave the sun's immediate environment and still spend thousands of years inside the emptiness before another star becomes close. The space between stars is not like the space between planets. It is another scale entirely. Inside the solar system, there are landmarks. The Moon, Mars, the asteroid belt, Jupiter, Saturn, Uranus, Neptune. The Kuiper belt, even if they are far apart, they belong to the same family. They orbit the same star. They exist inside the same system of sunlight and gravity. But beyond the solar system, the landmarks vanish. There is no planet waiting every few months. No station, no natural shelter, no halfway world where humans can stop and breathe. There is only distance, a deep darkness between suns. If a spacecraft left Earth heading toward Proxima Centauri, it would first have to cross everything familiar. It would pass the orbit of the Moon, then Mars, then the giant planets. Depending on its path, it would travel beyond the region where humans can still imagine the sun as the center of their daily lives. The sun would become smaller, less warm, less dominant. Earth would shrink behind the ship until it became just another bright point in the black sky. At first, the astronauts might still feel connected to home. Radio messages would arrive, mission control would speak, families would send recordings. Earth would still be a real place in their minds. But as the distance grew, communication would become slower. The messages would take longer. The delay would stretch minutes, hours, then more. Eventually, if the ship truly moved into interstellar space, Earth would no longer feel like a nearby home. It would become a memory, transmitting from behind, a voice from the past, and ahead there would be nothing visible that looked like arrival. Proxima Centauri would still be only a faint red star, a point in the darkness, a destination too far away to grow quickly. That may be the most psychologically difficult part of an interstellar journey. For years, maybe decades, maybe centuries, depending on the technology, the destination would barely change. On Earth, when we travel, we feel progress. A road moves beneath us. A city approaches. A coastline appears. Mountains grow larger. But in deep space, progress may be invisible. You could be moving faster than any human before you and still feel suspended in the same darkness. The stars would shift, only slowly, The sun behind you would fade gradually. Proxima, ahead, would remain distant. And the human mind would have to live inside that strange reality, moving constantly, but feeling almost still. This is why the journey to Proxima Centauri is not only an engineering problem, it is an emotional one, a biological one, a philosophical one. What does it mean to begin a journey that may outlast the people who started it? What does it mean to leave Earth when return may be impossible? What does it mean to aim for the closest star and realize that closest still means beyond anything humans have ever experienced? Proxima Centauri forces us to confront the difference between imagination and travel. We can imagine the star instantly. We can show it in a diagram. We can place it on a map of the galaxy. We can say its name in a second. But traveling there is something else. A name can cross the mind instantly. Light takes years. Matter takes far longer. And humans are slower still. We are short-lived creatures trying to understand a universe built on enormous timescales. Our bodies are shaped by Earth, by gravity, by atmosphere, by sunlight, by day and night, by seasons, by the rhythm of one small planet. But Proxima Centauri belongs to a scale where ordinary human rhythms begin to fail. A person can wait a few days for the moon, a few months for Mars, maybe years for the outer planets, if the mission is extraordinary. But tens of thousands of years, that is no longer a trip. That is history. That is civilization. That is a chain of lives. And so, the first question becomes clear. Could we ever make the journey short enough for humans? Could a spacecraft become fast enough to reach Proxima Centauri in one lifetime? Not in thousands of years, not in hundreds, but in decades. A journey someone could begin and maybe survive long enough to see the destination. To do that, we would need speeds far beyond anything we use today. Not slightly faster rockets, not a better version of what took us to the moon, not ordinary chemical engines. We would need a completely different level of propulsion. The fastest spacecraft we have built are extraordinary by human standards. They move through space at speeds that would seem impossible on Earth, but against a light year, they are slow. Painfully slow. A light year is almost 10 trillion kilometers. Proxima is more than 4 of those away. The distance is so large that even increasing our speed by 10 times would not be enough. Even 100 times faster than many current spacecraft would still make the journey enormous. To reach Proxima Centauri in a human lifetime, we would need to travel at a significant fraction of the speed of light. And that changes everything. At those speeds, space itself becomes dangerous. Tiny particles become threats. A grain of dust hitting a spacecraft moving at extreme velocity could release destructive energy. Radiation becomes more serious. Navigation becomes more precise. Energy requirements become almost unbelievable. And the ship cannot simply move fast. It must also protect the people inside. A tiny robotic probe is one thing. A human vessel is another. A probe can be small, light, minimal. It can fly past its target and send back data. It can survive without air, food, gravity, comfort, or hope. But a human ship must carry a world inside it. It must carry pressure, warmth, water, a breathable atmosphere, medicine, food production or storage, radiation shielding, waste recycling, power systems, backup systems, a crew capable of staying alive and mentally stable across the journey. Every human need adds mass. Every kilogram makes acceleration harder. Every safety system makes the ship heavier. Every heavier ship demands more energy, and the energy needed to push a large ship close to light speed is staggering. This is why many serious interstellar ideas begin with machines, tiny probes, laser-driven sails, uncrewed missions that could reach nearby stars much faster than any current spacecraft. A small probe accelerated by powerful lasers might one day fly toward Proxima Centauri at a meaningful fraction of light speed. It might arrive in decades. It might send back images. It might reveal what the system truly looks like up close. But that would not be the same as humans going there. It would be our eyes traveling first, not our bodies. And maybe that is how it must begin. Before humans can ever travel to another star, machines may have to make the journey for us. They would scout the path, test the technology, measure the dangers, send back data, tell us whether the dream is even remotely survivable. But even if machines succeed, the human journey remains a different challenge. Because humans do not only want to know that Proxima Centauri exists, we want to imagine standing there, seeing its red light with our own eyes, looking at alien skies, watching another star rise over a world that is not Earth. And that desire is ancient. It is the same force that pushed people across oceans, across deserts, across mountains, into the sky, toward the moon. But Proxima Centauri is not just another frontier. It is the first true test of whether humanity can become an interstellar species. Mars is another planet. Proxima is another star. That difference matters. A civilization that reaches Mars has expanded beyond Earth. A civilization that reaches Proxima has crossed the space between suns. It has stepped out of its birthplace in the deepest sense. The solar system is our cradle. Proxima Centauri would be the first neighboring fire in the dark. And yet, when we look at Proxima itself, it does not seem grand. It is not a giant blue star, not a blazing white sun, not a spectacular object dominating the sky. It is a red dwarf, small, cool, faint compared to the sun. Red dwarfs are the most common stars in the galaxy, but they are difficult to see with the naked eye from far away because they are dim. Proxima Centauri is so faint that even though it is the closest star to us, it cannot be seen without a telescope. That is almost poetic. The nearest star beyond the sun, hidden from human eyes, not bright enough to call attention to itself, not dramatic in the night sky, just a small red ember in the darkness. And still, it may hold planets. One of the most famous possibilities is Proxima b, a planet discovered orbiting within the region where temperatures could, in theory, allow liquid water under the right conditions. That does not mean it is Earth-like. It does not mean life exists there. It does not mean oceans are waiting. A planet around a red dwarf faces many challenges. Red dwarfs can be active. They can produce powerful flares. A planet close enough to receive warmth may also be exposed to intense radiation. It may be tidally locked, with one side facing the star and the other turned toward darkness. Its atmosphere, if it has one, may have been damaged or stripped over time. There are many unknowns, but even uncertainty is enough to make the destination fascinating. Because Proxima b is not an idea in mythology. It is not a fictional world. It is a real candidate world around the nearest star to the Sun, a place where the question of habitability becomes painfully tempting. What if there is an atmosphere? What if there are clouds? What if one side burns under red light while the other freezes under endless night? What if the edge between day and darkness contains strange weather, strange chemistry, or even some form of life? We do not know. And that ignorance is part of the pull. Proxima Centauri is close enough to become the first dream of interstellar exploration, and far enough to remain almost unreachable. It gives us just enough hope to imagine, and just enough distance to humble us. A journey there would be unlike any journey humans have ever taken. It would begin with Earth still alive behind us, oceans turning, cities glowing, clouds moving, the moon following its ancient orbit. Then the ship would pass outward, through the solar system, past the planets we know, past the outer darkness, past the fading edge of the sun's influence. The crew would watch the sun become a star, not the sun as humans know it, not the golden disk of morning, but a point of light behind them. And ahead, Proxima would grow slowly, a red point, a destination measured not in days or months, but in the endurance of civilization. Somewhere during that journey, the emotional meaning of home would change forever. Earth would no longer be a place they could return to easily, perhaps not at all. The astronauts would become people between stars, not belonging fully to Earth anymore, and not yet belonging to any new world. They would live in the most unnatural place humans have ever imagined, the space between solar systems, the true ocean, the deep dark between suns. And maybe that is why Proxima Centauri matters so much. It is not the most spectacular star. It is not the largest, not the brightest, not the most distant. It matters because it is first, the first possible destination beyond the sun, the nearest challenge, the smallest step into the galaxy, and still nearly impossible. If humanity cannot reach Proxima Centauri, then the galaxy remains something we can observe, but not enter. A vast, glowing structure seen from the shore. But if humanity ever does reach it, even with machines first, even with probes, even after centuries of preparation, then something changes. The stars stop being only lights. They become places, and the universe becomes larger and closer at the same time. That is the strange power of this journey. Proxima Centauri is terrifying because it shows us how far away even the closest star truly is. But it is also beautiful because it gives humanity a direction, a target, a first step, a red star in the darkness saying, if you ever want to leave the sun behind, start here. And so, part 1 begins with this truth. The journey to Proxima Centauri is not terrifying because it leads to the unknown. It is terrifying because the unknown begins so close. The nearest star is already beyond a human lifetime. With our current machines, the nearest planet beyond our solar system may be unreachable. For generations, the closest cosmic neighbor is distant enough to make Earth feel almost trapped. And yet, we keep looking at it. We keep calculating. We keep imagining, because somewhere deep in the human mind, distance has never been enough to kill curiosity. The stars are far. The journey may be impossible today, but the dream remains. And Proxima Centauri waits, small, red, silent, at the edge of everything humanity has ever known. Before any human ship could truly begin the journey to Proxima Centauri, it would first have to escape the world that created it. That sounds simple when we say it quickly. Leave Earth, travel outward, aim for the nearest star. But in reality, the first part of an interstellar journey may be one of the most difficult steps of all. Because Earth is not just a starting point. Earth is a prison of gravity, a beautiful prison, a living prison, a world wrapped in air, water, clouds, oceans, weather, and life. Everything about us belongs to it. Our bones were shaped by its gravity. Our lungs were shaped by its atmosphere. Our minds were shaped by its skies, its seasons, its colors, its sounds. And before humans could ever reach another star, they would have to separate themselves from all of that. Not for a few days, not for a few months, but perhaps forever. A mission to Proxima Centauri would begin with fire, engines burning, a spacecraft rising from Earth, the ground shaking beneath it, the sky tearing open as the ship climbs through the atmosphere. For a few minutes, the journey would look familiar. Like other launches, a rocket fighting gravity, a trail of flame behind it, the planet falling away beneath the crew. But then the mission would become something no human has ever attempted, because this would not be a journey to orbit, not a trip to the moon, not even a mission to Mars. This would be the beginning of a departure from the sun itself. The spacecraft would not simply be leaving Earth, it would be leaving the entire solar system. And that changes the emotional weight of every kilometer. At first, Earth would still be close. The astronauts could look back and see the blue planet filling the window. White clouds moving over oceans, continents glowing with city lights on the night side. A world that contains every human story ever lived, every language, every memory, every person they have ever loved. From orbit, Earth does not look fragile because it is small. It looks fragile because it is alone. A thin atmosphere, a blue curve, a living island surrounded by darkness. And for the crew heading toward Proxima Centauri, that view would not be a temporary moment. It would be goodbye. As the ship traveled farther, Earth would shrink, first into a globe, then into a bright dot, then into something that could only be found by instruments. At some point, the astronauts would no longer be able to look back and see home as a place. They would see only the direction where home used to be. That is when the journey would become real. Because leaving Earth is not only about distance, it is about losing scale. The human mind understands home through closeness, through streets, rooms, faces, voices. But deep space removes those things one by one. A city becomes a continent becomes a planet becomes a point. Then, even that point disappears into the background of stars. The crew would still know Earth exists. They would still receive messages from it for a long time, but emotionally, the relationship would change. Earth would become less like a place they can return to, and more like an origin, a beginning, a memory moving farther behind them. Before the spacecraft could reach interstellar space, it would have to cross the planets, not physically close to each one necessarily, but through the enormous structure of the solar system. The Moon would be the first familiar marker behind them, then Mars, then the asteroid belt, then Jupiter's region. Farther out, the giant planets would become distant symbols of the system they were leaving. The ship might use gravity assists, or it might follow a different advanced trajectory, depending on the technology available. But no matter the path, the emotional direction would be the same. Outward, away from the warm center of human life, away from the sun. The sun would remain bright for a long time. It would still dominate the sky through much of the solar system. But gradually, it would begin to change. Not physically, not in itself, but in the eyes of the travelers. Near Earth, the sun is not just a star. It is morning, heat, daylight, life. It is the difference between night and day, between winter and summer, between growth and silence. But from far away, the sun becomes a bright point. Its warmth weakens, its psychological presence fades. And this may be one of the hardest transformations for the crew to feel. The sun, which once filled the sky, becomes one star among others, still brighter than the rest at first, still familiar, but no longer the golden center of existence. For a human mind, that shift would be enormous, because every person who has ever lived on Earth has lived under the same sun. Every ancient civilization, every ocean crossing, every birth, every city, every fear, every dream, all beneath one star. A journey to Proxima Centauri would be the first journey where humans do not merely travel under the sun, but begin to leave it behind. Eventually, the ship would cross the outer regions of the solar system, past the orbit of Neptune, past the Kuiper belt, past frozen worlds and ancient icy bodies drifting in deep cold. These regions are not empty, but they are sparse, dark, slow, distant from everything human beings naturally understand. The sun's light is still there, but weak. The planets are behind. The ship is moving into the borderlands, and then, after traveling far beyond the planets, it would approach the heliopause, the edge of the sun's bubble. This is not a wall, not a visible border, not a shining line in space. It is the region where the solar wind, the stream of charged particles flowing outward from the Sun, loses its dominance against the interstellar medium. Inside this bubble, the Sun still shapes the environment. Outside it, the spacecraft enters the space between stars. True interstellar space. That phrase sounds beautiful, but it is also deeply unsettling. Because interstellar space is not a destination. It is the absence of destinations. It is the dark between homes. For the first time, the spacecraft would be outside the main protective influence of the Sun. Behind it, the solar system. Ahead of it, Proxima Centauri. Around it, almost nothing. This is where the journey becomes psychologically different from every mission before it. A spacecraft going to Mars has a clear target. A spacecraft visiting Jupiter has a giant planet ahead. Even a probe moving through the outer solar system can still be described as exploring the Sun's domain. But a ship to Proxima Centauri would spend most of its journey between systems, neither here nor there, not close to Earth, not close to the destination, suspended between two stars. For humans, that middle region may be the hardest part, because it would not last days, it would not last weeks. Depending on the technology, it could last years, decades, or far longer. If the ship were advanced enough to reach a significant fraction of light speed, the journey might fit within a human lifetime. But even then, it would be one of the longest continuous separations from Earth ever experienced. There would be no emergency return, no nearby station that could arrive quickly, no planetary surface to land on if something goes wrong. The ship would be everything: home, shelter, hospital, farm, engine, community world. Every system inside it would matter. The air system would matter. The water recycling system would matter. The engines would matter. The engines would matter. Even small failures would feel different because of the distance. On Earth, a broken machine is an inconvenience. In deep space, a broken machine can become a survival question. This means an interstellar ship would need to be almost obsessively reliable. It would need redundancy built into every important system. It would need repair tools, replacement parts, maybe even the ability to manufacture components on board. It would need crews trained not only as pilots or scientists, but as engineers, doctors, farmers, psychologists, and emergency responders. In a real mission to Proxima Centauri, the astronauts would not be passengers. They would be caretakers of a tiny civilization, and the ship would have to be designed not just for travel, but for endurance. A short mission can survive with supplies. A long mission needs cycles. Water must be cleaned and reused. Air must be refreshed. Food must either be stored in enormous quantities or grown. Waste must become part of the system rather than simply discarded. The spacecraft would need to behave like a closed ecosystem. Not perfectly like Earth. Nothing artificial can match Earth's complexity, but enough to keep life stable across the journey. This may sound technical, but it is deeply emotional, because the crew would be living inside a world that can fail. On Earth, nature carries us. Trees produce oxygen. Rain renews water. Soil grows food. The atmosphere surrounds us, whether we think about it or not. On a ship to Proxima Centauri, survival would be visible, mechanical, artificial. Every breath would depend on systems built by human hands. Every drink of water would be part of a cycle that must keep working. Every meal would be evidence that the ship is still alive. And outside those walls, nothing, no backup biosphere, no open air, only space. The dangers outside would be quiet, but constant. Radiation would be one of them. Cosmic rays, high-energy particles, solar activity from the sun in the early part of the journey, then the harsher background of interstellar space. Over years or decades, radiation exposure becomes a serious concern. The ship would need shielding, maybe layers of water, maybe advanced materials, if future technology makes them practical. But shielding adds weight. Weight makes the spacecraft harder to accelerate. The same pattern returns again and again. Human life requires protection. Protection requires mass. Mass requires energy. Energy limits speed. And speed decides whether the crew arrives within a lifetime. Then there is dust. Interstellar space is thin, but not perfectly empty. Tiny particles drift between stars. At ordinary speeds, they are not dramatic, but at extreme speeds, they become dangerous. A spacecraft moving at a significant fraction of light speed would turn tiny grains into high-energy impacts. The ship would need a forward shield, maybe layers of sacrificial material, maybe a cloud of particles projected ahead, maybe technology we have not yet invented. But the danger would always be there. The faster the ship moves, the more the empty darkness becomes a wall of invisible risk. That is one of the paradoxes of interstellar travel. To make the journey survivable in time, the ship must go fast. But going fast makes the journey more dangerous. Speed solves one problem and creates another. And still, the ship must keep going. The crew must sleep, wake, eat, work, repair, exercise, watch instruments, study the stars, because routine would become survival too. In deep space, the mind needs structure. Without sunrise and sunset, the ship must create time. Artificial days, artificial nights, lighting cycles, work periods, rest periods, ceremonies, meals, conversations, small habits to keep the crew human. Because the danger of Proxima Centauri is not only outside the ship, it is inside the mind. Imagine spending years surrounded by the same walls, the same corridors, the same mechanical sounds. No weather, no natural horizon, no crowd, no surprise, except the kind you fear. Every emotion would be amplified by isolation. A disagreement could become serious. Homesickness could become a pressure. The crew would have to be chosen not only for intelligence or skill, but for emotional endurance, patience, calm, trust, the ability to live inside a small world without letting the smallness break them. And the farther they traveled, the stranger communication with Earth would become. At first, delays would be manageable. then longer, then enormous. If the spacecraft were light years away, messages would take years to travel between Earth and the ship. A question sent home might not receive an answer for almost a decade, depending on the distance. A birthday message from Earth would arrive long after it was recorded. News would be old when received. Voices from family might belong to people who have aged years since speaking. The crew would not be part of Earth's present anymore. They would live in delayed connection. A conversation across light years is not really a conversation. It is correspondence with another time. This would create a strange emotional reality. Earth would continue changing behind them. New leaders, new cultures, new crises, new discoveries. But the crew would receive all of it late. They would watch Earth's history through messages arriving after the fact, and Earth would watch them the same way. The ship would become a story unfolding with delay. A human mission stretched across time. For the astronauts, this may feel like becoming ghosts of Earth, still alive, still connected, but never in the same moment. By the time they reached Proxima Centauri, Earth would be years older than their latest information. If the journey involved relativistic speeds, the time difference could become even more dramatic. The crew might arrive having experienced one span of time, while Earth experienced another. They would not only travel through space, they would become separated by time itself. This is what makes interstellar travel so different from ordinary exploration. The farther you go, the less home exists in the same present. Even if you return, the world you return to may not be the one you left. And if you never return, then the mission becomes a permanent branch of humanity, a piece of Earth sent into the dark. Perhaps this is why Proxima Centauri feels so symbolic. It is close enough to tempt us, but far enough to demand transformation. To reach it, humans may need to become different, not biologically different at first, but culturally different, psychologically different, technologically different. We would need to build ships that function as worlds, communities that can survive isolation, missions planned not in months or political cycles, but across decades, maybe centuries. We would need patience on a level modern civilization rarely practices, because Proxima Centauri cannot be reached by excitement alone. Excitement launches rockets. Patience reaches stars. And patience may be the rarest fuel of all. A civilization attempting this journey would need to commit to something whose full reward may not come quickly. It would need to fund, build, protect, and maintain a mission that might outlast many of the people who began it. It would need to think beyond immediate return, beyond quick success, beyond the human desire for fast results. This may be one of the greatest challenges. Not building the engine, not designing the shield, but becoming the kind of civilization that can start a journey knowing it may not personally see the ending. That is very different from how most human projects work. We like results. We like progress. We can measure. We like missions that begin and end within a career. But interstellar travel may require a new kind of ambition. An ambition not owned by one generation. A chain dream. A dream passed forward, and perhaps the first travelers to Proxima Centauri would understand this better than anyone. They would know they are not simply going somewhere. They are carrying humanity's first attempt to cross the darkness between suns. Every kilometer would be history. Every day would be farther than any human has ever lived from Earth. Every year would place them deeper into a region no living person has known. And yet, most of the journey would be quiet, not dramatic, not filled with constant spectacle. The terrifying thing about interstellar travel may be how ordinary it becomes inside the ship. Wake up, check systems, exercise, eat, study, repair, sleep, repeat, outside, the universe, inside, routine, a tiny human order moving through cosmic indifference, and somewhere ahead, Proxima Centauri, still distant, still faint, still waiting. The ship would approach it slowly, in the emotional sense, even if physically moving at incredible speed. The star would brighten, its position would become more important. The instruments would begin to detect more detail. Maybe planets, maybe magnetic activity, maybe flares from the red dwarf. The destination would gradually stop being a point and become a system. That moment would be extraordinary. For the first time, humans would not be approaching a planet of the sun. They would be approaching another star, a different center of gravity, a different light, a different system of worlds. The sun would be behind them, Proxima ahead, and the crew would be living through a moment no species from Earth has ever experienced. Arrival at another fire. But before that arrival comes the crossing. And the crossing is the true terror. The long middle, the years of darkness. The ship becoming home. The crew becoming separate from Earth's present. The sun becoming a star behind them. The nearest destination remaining impossibly far ahead. This is what Part 2 reveals. The journey to Proxima Centauri would not be terrifying only because of distance. It would be terrifying because of what distance does. It turns home into memory. It turns communication into history. It turns a spacecraft into a world. It turns astronauts into a society. It turns travel into endurance. And it turns the space between stars into the most silent ocean humanity has ever imagined. To reach Proxima Centauri, humans would have to cross that ocean, not with sails, not with courage alone, but with technology, discipline, patience, and a willingness to live inside the unknown for longer than any explorer before them. And somewhere in that darkness, far beyond the planets, beyond the warmth of Earth, beyond the comfort of the sun, humanity would discover whether it is truly ready to leave home. Because the hardest part of reaching another star may not be arriving. It may be surviving the silence between here and there. After years inside the darkness, after the sun has become only a bright memory behind the ship, something ahead begins to change. At first, it is almost nothing. A faint red point, a tiny ember in the black, one star among countless others. But slowly, very slowly, that point becomes more important than every other light in the sky. Proxima Centauri, the destination, the nearest star to the sun. For most of the journey, it would not look dramatic. It would not appear suddenly as a giant burning sphere. It would grow patiently, quietly. A red star becoming brighter across time. And for the crew, this would be one of the strangest emotional experiences in human history, because every traveler on Earth understands the feeling of approaching a destination. A city appears on the horizon. Mountains rise in the distance. A coastline becomes visible. An airport lights up below the clouds. But approaching another star would be different. There would be no landscape growing beneath them. No familiar sign of arrival. Only a faint red light slowly becoming the center of everything. For the first time since leaving the solar system, the ship would no longer be moving only through emptiness. It would be entering the territory of another sun, a new gravitational kingdom, a place where the sun is no longer the ruler. This may be the moment when the journey stops feeling like an escape and begins feeling like arrival. Not arrival at a world yet, not arrival on a surface, and that alone would be one of the greatest moments in the history of life on Earth, because every living thing we know began under one star. Every tree, every ocean, every animal, every human eye that ever looked at the sky, all of it existed inside the influence of the sun. But now, a human spacecraft would be approaching a different light, a small red dwarf, dimmer than the sun, cooler, older in its behavior, far less bright to human eyes, but still powerful enough to hold planets in orbit. Proxima Centauri is not impressive in the way people often imagine alien stars. It is not a blue giant blazing across space. It is not a huge golden sun dominating everything around it. It is small, faint, red, the kind of star that could easily be ignored if it were farther away. And yet, red dwarfs are among the most important stars in the galaxy. They are everywhere. They live extremely long lives. They burn slowly, patiently. Some may continue shining for hundreds of billions or even trillions of years, far longer than stars like the sun. In a universe where larger stars burn brightly and die sooner, red dwarfs are the quiet survivors, small stars with enormous futures. That makes Proxima Centauri fascinating. The closest star to us is not like the sun. It is a reminder that the galaxy is not built only around familiar stars. Most stars are stranger, dimmer, cooler, and smaller than the one Earth orbits. So, if humans ever arrived there, they would not find a second solar system exactly like ours. They would find something more alien, a star system shaped by red light, a system where planets must orbit close to receive enough warmth, a system where the star may be small, but its influence could still be harsh. Because red dwarfs can be deceptive. They look calm because they are faint, but many are magnetically active. They can produce powerful flares, sudden eruptions of energy, bursts of radiation that could affect any planet nearby. And this matters deeply, because a planet in the habitable zone of a red dwarf must orbit much closer than Earth orbits the Sun. Since the star is dimmer, a planet has to stay near it to receive enough energy. But closeness brings danger, more exposure to stellar activity, more gravitational effects, possibly tidal locking. A world around Proxima Centauri might always show the same face to its star. One side in permanent day, one side in permanent night. A world divided between red light and darkness. This does not automatically make it lifeless, but it makes it different from Earth in almost every way. Imagine arriving in the Proxima system and detecting a planet ahead, not just a point in data, not just a tiny change in starlight observed from Earth, but a real world visible to instruments nearby. A planet orbiting the closest star beyond the Sun. For the crew, this would be almost impossible to process, because for generations, humans looked at exoplanets as distant clues, a wobble in a star, a dimming of light, a mathematical signal, numbers on a screen. But now, after crossing interstellar space, those clues would become a place. A planet would no longer be an idea. It would be ahead of them, moving around a red star, waiting to be studied up close. Maybe the first decision would not be to land. Landing would be risky, perhaps impossible, depending on the planet's conditions. The ship might first enter the system carefully. It would observe from far away, measure radiation, map the star's activity, study the planets, search for atmospheres, look for moons, dust, magnetic fields, and hazards. After such a long journey, patience would matter more than ever. A crew that survived the crossing would not rush the final step. They would need to understand the system before trusting it. Because Proxima Centauri would not be a welcoming harbor just because it is nearby. It would be unknown territory. And the unknown around another star may hide dangers we cannot fully predict from Earth. The ship would have to slow down. That sounds simple, but it may be one of the hardest parts of the entire mission. Accelerating toward Proxima is only half the problem. If the spacecraft cannot decelerate, it would simply fly through the system at incredible speed, passing the destination like a bullet through darkness. A flyby might still collect data. It might send images. It might prove the journey possible. But for humans, a flyby would be almost heartbreaking. Imagine spending a lifetime traveling to the nearest star, only to pass it in hours or days, unable to stop, unable to stay, unable to orbit. True arrival means braking, and braking requires energy, planning, and technology, just as difficult as acceleration. The ship would need to reduce its speed enough to be captured by the system, or at least maneuver safely near it. Maybe it would use advanced engines. Maybe magnetic sails interacting with stellar wind. Maybe laser systems from the destination, if infrastructure had somehow arrived earlier. Maybe technologies we have not invented yet. But without braking, the mission is not a visit. It is only a glimpse. This is one reason interstellar travel is so much harder than it sounds. People often imagine reaching another star as the victory, but reaching it too fast is still a problem. The destination does not help you unless you can remain there. And if humans reached Proxima Centauri, remaining there would be the true beginning of exploration. The crew would enter a sky no human has ever seen. The constellations would be altered. The sun would no longer be the sun. From Proxima, Our sun would appear as a star in the distance, a bright star perhaps, but still only one point among many. This would be a profound reversal. For all of human history, every star was out there and the sun was here. But from Proxima Centauri, the sun becomes one of the stars. Earth becomes invisible. Home becomes something hidden around a distant point of light. The crew could look back in the direction of the sun and know that everything humanity ever knew was there. But they would not see Earth, not with naked eyes, maybe not even easily with instruments. They would see the star that once gave humans daylight, and nothing about it would look like home. That may be one of the loneliest moments imaginable. Not the darkness between stars, not the long silence of the journey, but arriving at another star and realizing that the sun has become part of the background. For the first time, humans would know what it feels like to be truly outside the solar system, not merely beyond its edge, but belonging, physically, to another star's sky. The Proxima system might not feel beautiful at first. It might feel severe, a red star glowing with a dim, deep light. Planets close in, radiation conditions uncertain, a sky shaped by a star that behaves differently from ours. If the crew approached Proxima b, they would need to know whether it has an atmosphere. An atmosphere changes everything. Without one, the surface could be exposed, harsh and silent. With one, the planet could have weather, pressure, clouds, and temperature patterns. But even an atmosphere would not make it Earth. The world could be tidally locked, one hemisphere facing the star constantly, the other facing endless dark. Between them, there might be a twilight region, a ring of permanent sunrise or sunset. If conditions allowed, this terminator zone might be one of the most interesting places to study. Not too hot, not too cold. A boundary between extremes. Imagine a world where the star never rises or sets, where one side of the sky always glows red, where the opposite horizon fades into permanent night, where winds might carry heat from the day side into the dark side, where clouds, if they exist, may behave in ways Earth's weather cannot fully prepare us for. This is the kind of place humans might find, not a second Earth, but an alien environment shaped by alien conditions. And perhaps that is more realistic. The first star we reach may not offer comfort. It may offer knowledge. The crew might discover that Proxima b is barren, or frozen, or stripped of air, or scorched by flares, or locked in a strange balance between extremes. They might find no life, no ocean, no welcoming surface, and still, the mission would change humanity forever. Because reaching another star is not valuable only if we find another Earth. It is valuable because it proves the stars are reachable at all. The first interstellar mission would turn the galaxy from something observed into something entered. That difference is enormous. A telescope tells us what exists. A spacecraft asks what it is like to be there. And humans, more than anything, want to know what places are like. Not only how far they are, not only what their mass is, not only what their orbit says, but what it feels like, what the light looks like, what the horizon does, what the sky becomes under another sun. If a landing were possible, it would be the most dangerous and symbolic step of the entire mission. The first human foot on a world outside the solar system, a surface that did not form around the sun. A rock beneath a different star. The astronauts stepping down would not just be exploring a planet, they would be breaking a boundary older than humanity itself. For billions of years, life on Earth existed in one system, one star, one home. Now, a living being from Earth would stand on a world around another sun. The emotional meaning would be almost too large, but the practical reality would be harsh. The suit would need to protect against radiation. The ground might be frozen, unstable, or chemically dangerous. The atmosphere, if present, might be unbreathable. The gravity could be different. The light would be redder. Shadows might look unfamiliar. The star might appear larger in the sky if the planet orbits close, but dimmer in color and intensity than the sun. And if a flare occurred, the surface could become dangerous quickly. The crew would need shelters, underground habitats perhaps, shielded structures, careful monitoring of stellar activity. A mission to Proxima b would not be about walking freely under alien skies. It would be about survival first, science second, wonder quietly threaded through both. And yet, even danger would not erase the beauty. Imagine standing in a protected habitat, looking through reinforced glass at a red star shining over an alien horizon, knowing that the light touching the surface comes from a sun no human had ever visited before, knowing that Earth is more than 4 light years away, knowing that every message home takes years to arrive. At that distance, communication becomes almost sacred. A simple sentence sent back to Earth would take more than 4 years to reach humanity, and the reply would take more than 4 years to return. A question and answer would require almost a decade. This means the crew would not be sharing discovery in real time. They would be writing to history. They would send images, data, voices, and observations into the dark, knowing that Earth would receive them years later. By the time people on Earth saw the first human images from Proxima Centauri, the crew would already have lived years beyond that moment. Every message would be a relic by the time it arrived. This changes the meaning of exploration. The explorers would not be celebrated instantly. They would be delayed. Their discoveries would travel behind them at the speed of light. Humanity would experience the mission as a series of echoes, a photograph from the past, a voice from years ago, a report written under a red star long before anyone heard it. And if something went wrong, Earth would learn too late. This is the loneliness of interstellar distance, not only being far, but being unreachable in time. Even light cannot make the connection feel immediate. At Proxima Centauri, the crew would be close in cosmic terms and still emotionally beyond reach. This is why any human mission there would need full independence. They could not rely on Earth to guide them. They could not wait for instructions. They could not ask permission for every decision. They would become humanity's first truly separate outpost, not a colony, perhaps, not yet, but a human presence outside the solar system. And once that happens, the idea of humanity changes. For the first time, humans would not be a single system species. we would exist around more than one star, even if only a small crew, even if the mission could never be repeated easily. The symbolic shift would be permanent. Before Proxima, all human life belongs to the Sun. After Proxima, life from Earth has touched another star. That may be why this journey matters so much. It is not only about Proxima itself. It is about crossing the first boundary. The galaxy contains hundreds of billions of stars, but reaching the first one would transform all the rest. The second star would still be difficult. The third, still dangerous. The galaxy, still enormous. But the psychological barrier would be broken. Humanity would know it can be done. Not imagined. Not simulated. Done. And once a species proves something possible, its future changes. The moon did that for Earth. Before Apollo, the moon was unreachable myth. After Apollo, it became a place humans had stood, still dangerous, but real in a new way. Proxima Centauri would do that for the stars. It would not make interstellar travel easy, but it would make it real. However, the system may also teach humility. If Proxima b is lifeless, it would remind us that distance does not guarantee reward. If it is dangerous, it would remind us that alien worlds do not exist for human comfort. If it is beautiful but uninhabitable, it would show us that wonder and survival are separate things. And if, against all expectations, it shows signs of life, even simple life, then the entire meaning of the universe changes. Because life around the nearest star would imply that biology may not be rare. If life arose independently so close to us, then the galaxy could be filled with living worlds, not necessarily intelligent, not necessarily familiar, but alive. That possibility would be one of the greatest discoveries in history. Yet, it would also raise new questions. Should humans land? Should we avoid contamination? Should we protect alien ecosystems even if they are microscopic? Should a world around another star have rights before humans understand it? A journey to Proxima Centauri may begin as exploration, but it could become an ethical test, because humans have often explored before, fully understanding what they might damage. On Earth, that has had consequences. On another planet, around another star, the responsibility would be even greater. If Proxima b were sterile, humans might study it freely. But if it were alive, even in the smallest way, then every step would matter. The first interstellar explorers would need humility equal to their courage. They would need to understand that reaching a world does not mean owning it. Seeing a place does not mean it belongs to us. The universe is not waiting to become human territory. It is already itself. And that may be one of the most important lessons Proxima could teach. The stars are not just destinations. They are realities. Independent, ancient, unshaped by human stories. We arrive late, we arrive with questions. But the worlds were there before us, and they will remain what they are, whether we understand them or not. As the crew studies the Proxima system, they may learn that the nearest star is not a second home. Maybe no planet there is safe. Maybe no surface can support people. Maybe the red dwarf environment is too unstable. Maybe the system is scientifically priceless, but not habitable. And if that happens, the journey still matters. Because the nearest star does not need to welcome us to be meaningful. It only needs to reveal the truth. The truth of what waits beyond the sun. The truth of how difficult habitability really is. The truth of how rare Earth may be. The truth of what kind of galaxy we actually live in. Perhaps the most emotional discovery would not be another Earth. It might be the absence of one. Imagine traveling more than 4 light years, crossing the greatest distance humans have ever crossed, arriving at the nearest star and realizing that Earth is still the only place that feels like home. That would be devastating, but also clarifying. It would teach humanity that exploration is not escape. We cannot assume the universe will offer replacements. We cannot treat Earth as disposable because other worlds exist. The first journey to another star might deepen our love for the planet we left. From Proxima Centauri, Earth would be invisible, but perhaps it would feel more precious than ever. A small blue world orbiting a yellow star. Warm, wet, alive, everything humans ever knew. Everything that made the journey possible. And maybe, beneath a red sun, the explorers would understand Earth more deeply than anyone before them. Because sometimes you only understand home after seeing how rare it may be. This is where part 3 rests. Not at the launch, not in the long silence of the crossing, but at the edge of arrival, where Proxima Centauri stops being a point of light and becomes a place, a system, a red sun with secrets, a nearby star that is still unimaginably far, a destination that may answer some questions and create far more. The journey there would test engines, shields, habitats, human minds, civilization itself. But arrival would test something else, our expectations. Would we find hope? Danger? A barren world? A strange atmosphere? A planet divided between day and night? A system too harsh for life? Or evidence that the universe is more alive than we ever dared imagine? No one knows. And that is why Proxima Centauri remains so powerful. It is close enough to study, far enough to dream about, and mysterious enough to remind us that the nearest star beyond the sun is still an unknown world waiting in red light. If humans ever reach it, they will not just be arriving at a destination, they will be arriving at a new chapter in the story of life from Earth, a chapter written under another star. And once that chapter begins, nothing about humanity's place in the universe will ever feel the same again.